Today's calculus tutorials will be covering the following derivative rules: power rule, exponential rule, and the logarithmic rule. These tactics are fairly simple and very easy to learn, and they are great, quick, and fast methods to use when finding the derivative. Okay, now for the first method. We have the power rule. The power rule is essentially the most fundamental derivative rule. It will be one that you will use a lot during your calculus course. So, the power rule states that let n be any integer other than 0 and a be some constant. Then the derivative of the function a times x to the power of n is equal to n times a x to the power n minus 1. So basically, the rule states that you take the current power and bring it down in front and multiply it with the coefficient of that term. Then you subtract 1 from the exponent and that gives you your derivative. Okay, so here are a few examples we can practice. Okay, so x to the 10th is our first example. So like the rule states, we take the exponent 10 and bring it down and multiply it by the coefficient, which is 1 in front of the x value, and subtract 1 from the exponent value, which leaves us with 9. So our final answer is 10x to the 9th. Okay, our next example is a little different since the exponent is negative, however the same exact rules apply. So again, we take the exponent of negative 4 and multiply it by the coefficient of 3, which leaves us with negative 12. And then we subtract 1 from the exponent value of negative 4, which equals negative 5. So our final answer is negative 12x to the negative 5. Okay, our last power example again is a little different but follows the same exact steps. So we have 2x to the 1/2 power. We take the value of the exponent and multiply it by the coefficient in front of the x. This is going to leave us with 2 times 1/2, which is 1. And then, like the rule states, we're going to subtract 1 from the exponent value. So 1/2 minus 1 is equal to negative 1/2. So our answer is x to the negative 1/2. But a more simpler term, which will probably be on the AP Calculus exam, it's going to be 1 over root x. Okay, so that sums up the power rule. On to the next rule, which is exponential. The exponential rule states that the derivative of an exponential function with base a, or a to the x power, is equal a to the x ln a. And yes, we can go through the whole limit process to see how they got this, but this is a much simpler version. So here are a few examples. First, we have 2 to the x. And like the rule states, we're going to copy paste the exponential problem, so 2 to the x, and multiply it by the quantity of ln a. And in this case, our a value would be 2. So our final answer is 2 to the x ln 2. There you go, it's as simple as that. So for the next example, which is the same exact problem except for the a is different, we're again going to follow the same exact rules. So we are going to copy and paste the exponential problem, 6 to the x, and multiply it by the quantity of ln a. And in this case, our a value would be 6. And there you go, that sums up our exponential rules. Finally, we are going to learn our last rule, which is the logarithmic rule, which is very similar to the exponential one. The logarithmic rule states that the derivative of a logarithmic function, such as log a x, is 1 over x ln a. Okay, so here are a few practice problems. So our first problem is log base 3 times x. So like the rule states, we take the value of x and multiply by the quantity of ln a, which in this case our a value would be 3. All taken to the negative 1 power, or it can simply be written as 1 over x ln 3. So for our next problem, we are going to follow the same exact steps. First we find a, which in this case is 6. Then we multiply x by ln a, which will be ln 6, all to the negative 1 power, multiplied by the quantity of negative 1. So we are left with negative x ln 6 all to the negative 1 power, or more simply written as negative 1 over x ln 6. Okay, so that sums up our lesson for today, and I hope you found this derivative rule tutorial helpful, and thanks for watching.